Yes, we can.
Yes. Now I am going to on my topic. My topic is statistical and machine learning analysis of cardiac event. It is my final semester project. I did with myself with the help of my supervisor, teachers, and friends. It is a project regarding heart disease. I skip the certificate and basic part. Okay.
Yeah, sure.
Now I am coming to the abstract. The main goal of my okay. Can you hear? May I audible?
Yes, you are completely audible.
Yes, yes, yes. And nowadays, I'm speaking about my project basic, about basic things of my project. Okay.
Yeah,
Nowadays, heart disease is one of the most visual disease among all of us, and it is the cause of certain death. We all know that. So my main goal is to find the exact pattern of the heart disease, which is the main reason, what kind of trend following the heart disease cause, etc. And also I use the gender wise comparison. Does heart disease is biased to male or female? And I'm trying to giving a particular pattern of my data set using some statistical model like logistic regression, machine learning, and identify the key features of my data set or model. Okay, I am going to the next page. Okay, is it clear?
so yeah, it's very much clear.
Okay, okay. Now I am coming to the objective of my project. uh, the main objective of my project is find a particular pattern of heart disease in this data set. Okay, I the and firstly I want to know the what is the gender wise trend. Does gender really factor or not? And I use EDA to know the pattern of my data set, to know the pattern of every factor which is related to the heart disease. And finally I use some model to know the what is the probability, and what is the chance to have heart risk. Yes or no? It is a binary logistic regression project. And also evaluate the performance, accuracy, precision, recall, F1 score through the confusion matrix. And I also use ROC and AOC to determine the reliability and robustness, means how the actually the thing is true or how the actually the thing is false. Okay, I am going to the next page. There are the basic data description of my data set. If the screen shared till now.
Yes, it's shared.
Okay, okay,
And
okay.
here, sorry to interrupt, but I have a question. I
Yeah.
can see the data set and I know you'll talk about it, but can you also tell the source of this data set?
Yeah. The source of the dataset is Kaggle data. Kaggle. I am taking the dataset from Kaggle. It is a synthetic data.
It's synthetic.
Yeah.
Uh,
At first, I am collect my dataset from source of National Medical website, but there are lots of issue with this dataset. Some are missing, some are unknown, and there are lots of issue, and it's trained high. I'm suffering from overfitting. That's why I changed my dataset, and there is a very short of time in my project competition. So the work is similar, but the dataset suddenly I change. Use synthetic data instead of real data.
okay.
Okay.
Yeah, it's fine.
Am-
We can continue
con-
and discuss.
yeah. At first I tell you the data description. Uh, uh, I want to know whether my hard disk is present. It is indicating by one or absent. Okay, it is a complete logistic regression model. We know binary logistic regression, and there are multiple covariate like heart rate, gender, age, systolic, diastolic blood pressure, blood sugar, CKMB, troponin level, etc. There are all are the numerical covariate except the gender. Okay, it is the first 5 row of my data set. Now I am discussing about the methodology which is used in this data set. At first, I use logistic regression. It is a very popular. It is a very popular method. Whether we want to know, is it really happen or yes? Actually, yes no type question. We can say that. Okay. There are some basic assumption of logistic regression. It might be a, which we all know that. Okay. I also use the log odds and I am the use another model random forest. It is a supervised machine learning model which are gathering of multiple decision tree to reach the actual decision means am I need to explain the random forest?
No, no. I think we are familiar with random for, but yeah, you can give like I will give you the
Okay, am I
chance to
uh,
explain it in very simply. If you can
okay I
explain it in two, three
okay
lines.
okay 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 I'm explain it with a very basic example. Suppose you want to go summer vacation, you don't know what is the better place between Kolkata and Mumbai. Okay, some of your friends say it is Kolkata, some of your friends say it is Mumbai. At first you go your friend, he say Mumbai, but you thought that I need to ask another friend. Then the another body is say Kolkata. Okay, so you ask multiple people to know the what is the better. So majority of the vote is come to Kolkata. So you choose Kolkata. Much means can you understand this? What I tell?
Yes, basically, you. I think you're trying to illustrate that random forest is a collection of multiple trees that help
Exactly,
us
multiple decision
make the
to reach the
decision.
decision, and which decision is
That's
voted by majority.
Yeah, that was a very good example. Let we can proceed.
Okay, okay.
Liton, I think your screen just disappeared. Is there any network issue on your end? So I think he has network issue. He may join.
Hello,
Yeah,
hello. May I audible?
yeah, you are audible. No issue. I think you
Uh,
had. So you can reshare the screen and resume.
Extremely sorry for this inconvenience.
No issues. No issues.
Okay, I'm continuing for Man Whitney Utes. Okay,
You can
we
share
all
the.
are. Oh, X second, just a minute. There are lots of network issue in my area. Actually, I am staying near the airport area. That is the main reason of network issue. Can you see my screen?
Yes, I can. Before
Yes.
going to the man Whitney test, I saw that you were describing the models that you used.
Yeah.
So you gave a description of random forest, and initially you said you were doing a logistic regression model.
Yeah.
So
Yeah.
is it
Yeah.
that you experimented with logistic regression as well as random forest?
Yes, I am going to the background story of it. At first, the accuracy of the logistic regression is very poor in my data set. Okay, so I use another model, random forest, to know whether that which model is totally acceptable in respect with my data set. Is it clear?
Yes, it's clear.
Hi, now I am going to telling about Man-Whitney U-test. I think many of us is familiar. It is Man-Whitney U-test. It is just like a parametric test, t-test. Non-parametric version of t-test.
Can you also
Hello?
describe that why are we discussing about Man-Whitney U-test and then chi-square test of independence in the first
Yeah,
place?
yeah, yeah, yeah.
Like, what is their connection to the project?
Man-Whitney U-test is used for the comparing the all the cofactor related to the gender. Like I have two gender in my data set, male or female. Does the other factor like age, troponin level, CKMB, and etc. varies with respect to gender? That's why I use the Man-Whitney test. And we also know that Man-Whitney test is used whether the two groups are independent to each other. Okay,
Yes.
is it clear?
Yes. So essentially,
And
what you're
I
saying,
use
you
Sky.
want to
Uh,
kind of test on the on whatever outcomes you get on the basis of two variables. Here, in this case, it is gender
yeah,
or sex, which is male, female.
or female. Okay. And finally, I use the chi-square test. Between chi-square test is used between two categorical data sets. We all know that. In my dataset, the two categorical dataset is gender and the result. Does gender and result as a significant association or not? Okay. Now I am coming to the main EDA part. Okay. There are some basic description about count plot, violin plot, and confusion matrix. Am I need to explain all of this?
No, no, you don't have to.
Hello.
You have a visualization of this violin plot later in the
Yes, yes, yes,
PDF.
yes,
Okay, yeah. When it
yes,
comes,
yes.
then you
It is
describe.
done in later.
Hmm.
Okay, okay. At first, I checked. Now I am come and data analysis. In a project, it is our first work to check whether the data set contain null value or not. Is it right? Actually, in my data set, there are no null value. You can see that zero null value, gender, heart rate, there are zero. Okay, and there are the little bit summary of my data set. What is the how many number of male female, how many number of person, what is the mean standard deviation of the age, minimum age, maximum age, interquartile range. Okay.
Here, I have a question.
I
If,
use
if you
yeah,
go up
yeah,
to the table once again, I see that the gender column in this. See, gender seems like a categorical variable, but here we are seeing that there is mean
yeah,
deviation minimum value as well. So, what
yeah,
should I
that is
understand?
a drawback of my project. Yes, yes. I did it wrong, I did it wrong,
No,
I did
not
it wrong, sorry.
necessarily. You could also have gender as
I need to
indicator.
rectify this.
So,
Yeah, 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 gender is a categorical I
what
am
it looks
understanding your point. You are right. Actually, no one. Yeah, yeah. Actually, no one correct me in such way. So I forget. It's my fault. I am not. It's totally my fault. I am correcting it after this session.
yeah, that's not a problem. So I think now let's be very no issues at all. We can be very curious right now. So what it can it so happen that one is for female and zero is for male, like indicator variable.
Yes, 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 yes.
You
Sorry,
can
sorry.
check that.
There are a little mismatch. One for one indicating the male and zero indicating the female.
Okay. Uh, Other variables look to me as numerical itself, so it seems fine. So
Okay, okay.
can we have like looking at these numbers, can you comment whether the distribution of any particular variable is symmetric? What
Yes, yes, yes. Yes, yes, yes. I am coming this point after this.
okay, sure.
Okay, okay. And I also pre-compose my preprocess my data set by using the interquartile range or Z score Z-score method, because in medical dataset we know there are lots number of outlier present. So I use some method which make my model more good. Okay, Z-score method at interquartile range. Now I am coming to the main exploratory data analysis system. Okay, analysis. At first I did correlation matrix. What is correlation matrix? Correlation matrix is a matrix where we can find out the pairwise correlation. Okay, so we seen in this matrix that there are very few there are no correlation among all the factors, and moderate correlation between systolic and diastolic blood pressure because it is come from a same physiological system. Is it clear?
Uh,
Hello.
I could understand that there is no correlation between most of the variables,
Or
but can you explain what you
most
were
of the
saying
variable,
about
but huh.
blood pressure? How is blood pressure having correlation?
Can you give me 1 minute? Network is very interrupting. Can you give me just 1 minute?
Sure.
Just a minute. One more second. 1 more second.
Yes.
Just a minute. Just a minute. I am coming within 1 minute. Sorry for the interruption.
No issues at all.
I am coming at my house. Just a minute. Just a minute. Hello. May I audible now?
Yes, you are audible. You can share your screen and
Sorry for the interruption. Extremely sorry. I am suffering for very low network.
yeah, it's okay. Do you think you can share the screen? Do you have that much network?
Haha, now I am at my brother's house. No issue.
Okay.
Yeah. Now, check. Can you see the correlation matrix?
Yes, yes, we can see the mail.
In my correlation matrix, I see that many others covariate like age, heart rate, systolic, diastolic, blood sugar, CKMB. There are very few correlation or almost negligible. You see there 0.02, 0.-02, very negligible. But there we found a moderate correlation between systolic blood pressure and diastolic blood pressure because they are came from same physiological structure in our heart. We know that. Yeah, look at the correlation 0.59 and 0.59 between systolic blood pressure diastolic blood pressure. Okay, is it clear?
Yes, wait just a second. One, two, three. Okay, yes. I think there is a printing issue in the x-axis if you see, because the third point is, but yeah, it's just a graphical glitch. It's fine.
Okay, am I going to the next? Am I going to next page?
Yeah, you can continue.
Yes. Now I analysis the gender wise analysis. What is gender wise analysis? I use gender analysis because I want to know whether there are exact any difference the trend of other factor like heart rate, CKMB, systolic, diastolic, etc. Okay. At first, in my dataset is very biased. Bias means there are lots number of male. Male is indicating one and zero is indicating the female. Okay, there are it is a biased data set towards the male. Okay, am I audible?
Yeah, so do you
Huh. I am going to the
understand
next
if
slide.
biased is appropriate in this case? There is a larger representation of males, yes,
Yeah. There are
but
larger representation of men in my data set.
you can. Okay.
Okay, at first I want to know the what is the age distribution of gender. Okay, you can see the distribution curve of gender.
Okay.
Is it seen?
Yeah, it's visible. So, what do you think? Can we comment that both the male and female gender, I mean,
Are
age distributions have the seem to have
almost
the same
almost
center?
symmetric. It is almost symmetric. In male, we see that maximum heart risk patient are belong to 50 to 70. Okay,
Okay.
and female are moderately after 40. It is the main heart risk age of both female and male.
Okay. But wait, go up again once. I have a question.
Yeah.
So here we cannot say heart risk, right? Because your data, I'm assuming your data has some observations as patients with heart risk, but some observations are also patients who don't have heart risk, right?
Actually, in this graph, I want to know the what is the age distribution of my data set among male and female.
Okay, so exactly that is what I'm trying to say. So it means if we look at the male population, it has the mixture of heart patients and not heart patients as well.
Yes.
Is it correct?
Yeah. Also for
Yes.
the same of female.
Yeah, so that is why we cannot make the claim that heart patients are, just by looking at this graph, we cannot make the claim that heart patients who are male are mostly between 50 to 70, because this is considering both kinds of male observations, patients with heart disease and not without heart disease as well. So we cannot say that, make a direct inference about heart disease once, right?
Yeah. You are absolutely right. Absolutely
Okay.
right. You are. I'm going to the next slide.
Yeah.
And now I am comparing blood sugar distribution by the gender in heart attack patient. Okay, it is. I am comparing the it's in heart attack patient only.
So you have So I'm asking, the way you have ensured that is that your data set must have the condition that wherever the heart attack indicator is 1, you must have chosen that only.
Yeah.
Okay.
We've seen that most of the patient whatever it is, male or female, the general heart attack or below general blood sugar belong to 100 mg per liter, and it is quite natural. We know that blood sugar.
So just a curious question. So does it actually happen that lower blood sugar is correlated with higher heart attacks? Is
No,
it
I don't claim that from this view.
okay? It was a biology based question, but yeah,
Yeah,
okay.
yeah, it is totally biology based question. As secondly, I used to compare troponin level in gender. I've seen that most of the patient belong to the natural troponin level, but there are some very few outlier, which is very high. And we know that troponin is a major factor in heart risk. Is it clear?
Yes.
The next picture. The next feature, I use the systolic blood pressure between heart attack patient and both male and female, and it is seen that the maximum male and female heart attack belong to in 130 to 140. In this violin plot, you seen that there are major number of patient blood sugar belong in this range. 130 to 140. Okay, it is pre-diabetic stage. We can say from that. Okay. And next, we see that the diastolic blood pressure between male and female, and it's claimed that it is very quite normal. It is belong to 80 to or 70. We know that the general pressure level 120 and 80. Okay, so we say from this we say that our diastolic is normal, but the systolic is belong into pre-diabetics level. Okay, is it clear?
Yes, you can proceed.
Next, I find that there are correlation. At first, I told you that there are moderate correlation between systolic and diastolic.
Yes.
In our data set, we claim that from the picture that systolic blood pressure is almost double of diastolic blood pressure. It is indicating a heart risk,
So
pre
are
heart
you
risk. Huh.
that when systolic blood pressure is roughly twice the diastolic blood pressure, then there is increase of heart risk.
Yeah. I'm claim that from that picture, and you see that there are a linear pattern in systolic blood pressure. In red dot, it means that heart attack patient, and the green dot indicating the no heart attack patient. And you see that the maximum people are belong in 125 to 150. Look at the systolic blood pressure.
Hmm.
Okay, is it clear? As some are very outlier.
Okay, that's a nice insight.
Actually, there are lots of outlier in my data set. It is a medical data set, so I am trying to remove the outlier, but I don't. I can't that. Next, I use CKMB level in heart attack patient throughout the gender. It is quite normal between male and female, but there are some outlier which claim that which indicating that the high CKMB is heart attack indicator. Okay, according to biology. Next, I use heart rate in heart attack patient. There are few outlier, and it is a quite normal, but some patient belong to high heart rate. Now I use a measure which is features importance, which help the what is the important features in our model, like means that what are the important covariate. from that, I claim that age is a very important covariate for heart attack. We also know that the heart attack is happen after a certain age. Is it clear?
Yeah, it is.
Most of heart attack are happen after the 50 or 60 from our neighborhood. We know that. Also, the troponin and ckm is also important factor. And there are after that gender is a create a little bit factor, and blood sugar also. Okay, now I am going to the result analysis. Okay,
Okay.
just a minute. I take a deep breath. Now I use gender-based comparative analysis using the Mann-Whitney U-test. What is this? I know the I want to compare. Does there are other factor like like age, CKMB, troponin, heart rate, blood sugar, vary due to the gender. It is the null hypothesis distribution of continuous variable for the both gender is same and alternative is deeper. Okay, and you see that the u statistics and p value also from my data set. And I claim that just a minute, I want to take some water. Okay, hello,
Yeah, yeah, it's fine. You can relax and proceed.
just a minute. I am back. Sorry. Now from the Manhattan U test, I see that the U statistics value and p value. From that, I claim that only two things are varied due to gender. That is CK, that is troponin and age in heart attack. Okay,
So basically, you're saying that out of all the variables,
yeah,
only this troponin and the other one is
age and troponin,
significantly different when we bring
significant.
it into the picture.
Yeah, yeah. When it's come to the topic of gender, the age and troponin levels are significantly create a factor in heart attack. Okay,
Yeah, and wait, let me
now
just. So yeah, so you are essentially while you were doing this test, say for troponin, you divided your data set. You had two data sets for the man-Whitney test. One was troponin for male, and other was troponin for female.
yeah,
But my question is,
I
there
say
did you also check whether the troponin for male and troponin for female were they both of patients with heart attacks or overall?
no, no, it is based on the heart attack patient. I use some Python code which extract the heart attack patient.
Okay, so it's not all the males and all the females, it's only
No, no,
those
no, no.
males
Now
that have heart attack
exactly
and
who have heart attack, or those female who have heart attack.
okay.
Okay, now I am came to the model evolution. Okay, at first before I telling you that I use logistic regression model, and this is our regression model is x1 is denoting age, x2 is denoting heart rate, and etc. And I use to change my I used to change the categorical factor, which is gender, into numerical, which is by hot encoding. Okay.
Okay. So suppose I have a question for you. Here we have only two genders. Suppose there were three genders, male, female, and other. So how would the numerical representation be then? Can you give an
Doesn't, yes, yeah, doesn't matter. I am representing the one by males, two by female, and three by others. I am just hot encoding it.
Okay. But would it not? Okay, so suppose you are doing this, would it not create a, for two it is fine, but say for more than two, would it not? I'm just asking. I myself don't know. Would it not create a bias in the sense, say, when
Yes,
this
yes.
one three goes into the algorithm,
Ha ha.
maybe
The
it will
covariance is
it's
created a factor.
it becomes an ordinal variable. One is greater than less than two, two is less than three. So can it not create an issue?
Yes, yes.
I
It can be a issue.
I don't. So what
Yeah,
could be an
I
is
also add it in my future scope of my model. There are little bit a drawback in my project, and it is one of them. When it's come to the three, what I do actually, I am also don't know the what is the my next step. I need to study about it.
yeah. I think one thing that you can do, we all can do over here is this. I don't remember whether it's called one hot encoding or target encoding. So essentially, what target encoding does is it takes the categorical variable and it connects it somehow with the target variable, which in this case is the heart attack, and then it will convert that categorical variable into certain numerical values with association to the target variable. That is something that you can research and check out later if you get time.
Okay, okay. I'm work on it. I will work on it. Okay.
Yeah, okay.
So now I am continue.
Yeah, sure.
Uh-huh. Now the pseudo r square value of my data of my model is 0.35. It's mean 35%. Which indicate there is a decent fit in my data set, in on the base of logistic regression.
Mm.
And now I am say the what is the what which factor are significant in the case of heart attack, based on p value on the of coefficient. Okay, our target at first I set a p value 0.05, which is level of significance. We all know that. So with compare this with compare this level of significance, we see that only age, CKMB, troponin, and gender are significant in the case of heart attack. Okay, is it clear? Am I need to explain it once more?
No, yeah, it's pretty clear.
From this chart we see that only age, troponin, CKMB, and gender are literally factor in heart attack, and others are no more important for us. And now I am doing chi-square test. You
No,
at
just
sometime
for
with
the square test, just the paragraph above it, I saw a very interesting line that you have this interesting comment on the odds ratio for
yeah,
troponin.
yes.
Can you explain that?
Odds ratio means that what is the either it is a ratio of either it is happening or not happening.
Hmm.
In this case, I see the odds in the odds of CKMB are very high. So we indicate that the numerator part of odds ratio is high. So it's claim that CKMB is an so maximum patient have high CKMB.
So, what it also, like your paragraph beautifully, I think, brings out is that if there is slight change in or slight increase in the value of CKMB, then the likelihood of getting a heart attack increases a lot, it seems. That's because the odds ratio is very high over here.
Yes, yes, the odds ratio is very highly for my for CKMB. Can I go to the next slide?
Yes. Yes.
And now I use chi-square test of association between gender and heart attack. We all know that chi-square is used whether the both fact both whether it comes in the firm case of both categorical data set. Okay, so gender is a categorical and heart attack is also categorical in my data set. So I want to know whether there are significant association between gender. It is my null hypothesis. And also my alternative hypothesis is gender and heart attack are not independent. Means there are as association between them. Okay, is the hypothesis are clear to you?
Yes, it is.
From the contingency table we say that uh, gender from the contingency table you just see that the p value of it 0.0173, which indicate that gender or heart attack are not independent, they are significantly associated. Okay, now I come to the main matrix and classification report evaluation. From the logistic regression I see that there are multiple incorrect classification. uh, uh, Negative, in the case of negative heart rate, negative means here there are no no heart attack, and positive means yes. Okay, so we know that there are 29 negative but which is identified at positive, and there are 24 positive which is identified as negative. So it is a not a good fit model. There are lots of misidentification, and the accuracy of the my dataset is 79.92%. Is it clear?
But why do you? Okay, I just saw that below you have done random forest as well, and here the accuracy is more than 80%. But here also logistic regression accuracy is 80%. So why do you think 80% is not good enough?
80% is not good enough because there are lots of misidentification. You see that 29 and 24 are misidentification, which from this I cannot identify that which patient have heart attack or not. So that's why I claim that logistic regression is not a decent fit or decent model in about with respect to my data set. Our main motive is identify that which patient have heart attack or not, and try to give them best treatment to rescue from the disease. So here there are very misidentification. How can I say that it is a good model?
Okay,
Is it
let's.
clear?
Yeah, what do you have in random forest? Let's see that.
In random forest model, I see that there are 100 negative. There are very good identification. Only four misidentification in compared to logistic regression. Very little bit misidentification, which help the medical team to identify which patient have uh, heart disease or not, and the accuracy of my data set is 98%, almost 99.9. Okay.
Yeah, that's very good. Just like logistic regression, you had given us the variables which were important to do the prediction.
Yes.
What about random forest? What variables are important over here? Do you have
Yeah,
a?
yeah, 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 yeah. I do it. I did it.
Hmm,
In random for on the base of random forest, troponin is the main important factor.
okay.
You see
So
the
means
score of troponin.
CKMB yeah. Okay. One
And
good thing is I see the consistency. Even in logistic regression, there were
yes,
troponin,
troponin
CKMB.
and CKMB is very important. And whenever it comes to the random forest, it's also important. CKMB, troponin, and age. Okay.
Yes. So one more, like
Yeah.
over there, we also had coefficients for
Yes, yes,
logistic. So, for instance, CKMB had a positive coefficient, so we could infer that increase in the value of CKMB means higher risk of heart attack.
yes.
But
All.
here
Uh-huh.
we don't have we have just the overall aggregate view that these features are important, but how exactly are they associated with the target variable? Do you have any views on that for
No, no,
random?
no. I am not doing that. I also add it in my future scope. My project is not complete till yet. It is just submitted for college work. I am also working on it.
Okay. So one thing that you can do is I'm not able to recall, but there are many. If you search using Chat GPT or otherwise, there are good libraries that help you explain the splits in your random forest. So random forest is basically a collection of decision trees, and each decision tree is like a collection of if-else split, right? Starting from
Yes,
the
yes,
first node, if a variable value is greater than this, it will go to the left side, otherwise right side.
yes, yes.
So with that, we can see the association of variables. So there are visualization packages and explainability packages in Python that can help you get the interpretation of how your random forest is working. So I will definitely recommend you to explore that.
Okay, okay. I note that on my notepad. Finally, I am came at my last slide. ROC and AOC curve. ROC curve, which is a very good measure to identify that how the actual the model is working. In blue line, you see that logistic regression is very. The AOC of logistic regression is 89, and the AOC of random forest is 99. Okay, in compared to random chance. Okay, oh, you see that the distance between random forest and random chance is more far in compared to logistic regression. That means that random forest identify the true positive rate in compared to logistic regression. Is it clear?
Yes, that was also clear with the accuracy results that you had shown. It had almost 99% accuracy.
Yeah, yeah.
So how many trees did you use for the random forest?
Actually, how many days? Can you clear your question?
So a random forest is basically a collection of decision trees. So how many decision trees did you take for your random
Okay,
forest?
okay, okay, okay. Random data. Yes, it is used 100. Sorry, thousand.
1000. Did you try with other numbers?
No, there are the code random strata. It means that thousand time it's repeat the decision.
I'm saying, did you try with say values less than 1000? Say what is the performance in 100 decision trees, or 200 or 300 or more than 1000, or did you just stick with 1000?
Actually, I am just taking the thousand. It is a
So
standard. So, I from geek for geeks, it's clear. Note down. It's clear say that a thousand is a standard. Thousand is a standard measure of random forest. Thousand decision tree is a standard for random forest
that
to
is
reach
that
any
may be
decision.
correct. That may be correct, but I'll tell you why I said this, because it can so happen, you are aware with overfitting, right?
Yeah, yeah.
So it can happen that your random forest with the 1000 trees was so much that it did a complete overfitting on your entire data set. So what you can also do is consider a split between the data set where you have say 80% of the data set as your train and
Yes, yes,
20%
yes.
as
I did this 80% training data set, and I did this actually 70 or 30.
okay, even that is good. So you are saying the results that you showed us, are they on the test data set?
No, no, train data set.
Then you usually we should do something like this, that when we do the training on the trained data set, to see how much it can generalize, that how much robust our model is, we should use the test data set to see the performance. So that is something that you can look for in the future.
Okay, okay. I'm looking for it for future. And
Okay.
here is the end. Here is the final conclusion that random forest is better model fit in our data set which give at the which give a exact trend or evaluating the performance of the data set in compared to logistic regression. But here I have a question. I also asked my teacher, but the answer of them is not satisfied. Can I ask it?
Yeah, yeah, sure.
In this dataset, I use two models to for comparing. I see that logistic regression does not perform well. I use random forest. So how many model I need to compare? There are multiple models: super support vector machine, random forest, XGBoost, AdaBoost. So what number of model I can use?
Actually, I was going to ask you that question, but now that you have asked on the other side, it's actually a very, very good question that how many models should we can think about it in a very systematic way. Let's start at the base level. So all these two methods are supervised learning methods, right?
Yeah, yeah,
So one way to go about it can be looking at the very starting point and seeing how many categories of models I have with me. A very crude dichotomy is supervised and unsupervised. In supervised, you can again do a kind of ranking that which model is the most simple and then which model is more complicated. If I am
you
not, can you hear me?
act, I have a little question. You what you say, level or this level ranking? You say something about rank. Can you repeat this?
So you understood that we can start by looking at say supervised models and unsupervised models, right?
Yeah, yeah.
So now suppose you look at supervised models, there are very different kinds of supervised models. Linear regression, logistic regression, decision tree, random forest,
Random forest.
they are all different kinds of supervised methods, but there is a kind of gradation in the sense that regression models are more explainable than the decision tree and random forest models, right? Because you
Yeah,
have a very good interpretability on the coefficients. So one way to go about it is to make this gradation in supervised learning. What is the most simple model I can have? What is a model with medium complexity and what is a very complicated model but gives good results? And one way to compare is if your simplest model is able to give you that good of a performance as the complicated model, naturally you can just choose the simple model, because in real life also we want to choose models that are as simple as possible. Because think about it, if you are running a very big hospital industry or something, you would
okay.
want to keep things under control as much as possible. So if things are more complicated, it becomes more of a burden. So if a model is performing very good and the model is simple, our preference is usually to go for a simpler model. But if we see that according to say our business and our criteria, our simple model is not meeting the required criteria, like we saw that logistic regression, you said 80% accuracy was not enough, you wanted more. So in
Yeah,
that case, you can start exploring more complicated models, in which you also did. You chose random forest, which gave you a good accuracy. Similarly,
yeah.
you do the same thing for unsupervised learning methods also, uh, where you can use methods like k-means clustering and go on with more.
Bayesian, Bayesian method.
Yeah, and there is this approach with embeddings also, where you have various complicated models that turn your data set into various embeddings, and then you find the unsupervised learning on the basis of those embeddings. So all of these complications you can go layer by layer. So to answer your question in summary, you make a very systematic gradation that this is my base class of model, supervised, unsupervised. In this I have subclasses which is low, medium and high complexity, and that many models you explore, so that your project can also become rich with more number of models, and in the end you have a good, even now I think you have a good summary that on the basis of two models you have the better one, but there you will have better options to choose from, and whoever is viewing the project will feel that this person has done sufficient research.
Okay, okay, okay. I am also working on it. Thank you for the answer. Now it is satisfied to me, and I am
Okay.
also looking for another model which is suitable to my project.
Yes, yes. I think the more you study and learn, the more you can incorporate your latest education findings into this project.
Okay, okay. Thanks a lot. It is more helpful for me for this opportunity. I am very thankful to you and Obrodip Tadi.
Yeah, thank you for presenting your work. It was comprehensive. I think it covered a lot of things. I will give you some feedback offline as well. However,
Okay.
one curious question I have, you said you had original data in the first place. You were downloading it from some national medical source, but because the data had some nulls, you did not choose to go with it. Is it
Uh,
correct?
yes, yes. Actually, there are one another issue. The when the I take the my first dataset, it is actually all the dataset are categorical except age. So I am suffering from because there are also 80 15 covariate, out of them 14 are categorical and one is only numerical. So I am very tense and ask my teacher say that you cannot you can do anything, you have to work with it. So I am very puzzled, so I change my data set. The work is similar in the both case.
Okay, so your main problem was that the data set was very much categorical. Is that correct?
Yes, 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 yes.
So in that case, you could have also tried exploring how to convert categorical variables into numerical.
Actually, the all the things and in my previous address is 0 1 0 1 0 1. Either heart, either CKMB present, either CKMB not present. 0 1 that type.
Oh, okay. Very crude categorical.
So I
Mhm.
changed my data set, and it is also regretting for me to change a data set for my college project. It's also came in the matter. It is my college project. It's come with 100 marks. So I also bias with that. I'm also feeling very guilty for this, but I
No, I think it's very much fine. There's see, we have to be practical also. So
yes, yes.
it's
There are
to get
only 20, there are
you are
only
also
20 days
getting
left.
knowledge and you're also getting the marks. So it's a
Okay,
good. Don't feel guilty about it. Okay.
okay,
I
okay,
very
okay.
much like your learning spirit on the matter. So you can definitely pursue it further, this project with real data. Maybe you will get opportunity to have a richer data set which is real, and then you can use all of these methods that you learned in this synthetic data and take your work even to the next level. And you can
Okay.
also maybe end up finding very much good insights with your analysis. And because you will use real data, those insights can be consumed by, who knows, healthcare industries as well.
Okay, okay. I'm also working on it, and I also try to work with real data.
Yeah. But once again, thank you very much for your elaborate presentation today. And I would say it was comprehensive enough, and I enjoyed finding insights. Like my takeaway was that CKMB is a very dangerous thing, whatever it is. If it goes up, I am in trouble. I hope it is not going up for me or anybody else.
Yes, yes,
So
yes. I also pray that. And thanks for the opportunity to you.
okay,
And I'm contacting you furthermore.
yeah, sure. I think Spandan has a question or something. He raised his hand.
Does anyone
Spandan,
have any
do you
question?
have any question? No question.
Okay,
Just
okay,
wanted
okay.
to say thanks for that. Yeah.
Welcome, Spondon.
Okay.
Thank you.